Hello everybody, this is Mr. Wells, and for my FHS Trimester 2 Earth Science project, I'm going to be talking about the extinction of the dinosaurs. My learning target for this lesson will be to define unconformity, uniformitarianism, and index fossils. In order to understand the dinosaurs, we first have to have a talk about geologic time. So the dinosaurs lived for a very, very long period of time. In fact, the Stegosaurus on the left died about 90 million years before the T-Rex even walked the Earth. This difference is longer than the distance between the extinctions of the dinosaurs themselves, so the T-Rex, and humans right now. Index fossils can tell us a lot about life in the past, especially when we're thinking about extinctions. So index fossils are fossils that have a wide distribution over a narrow range of time and are characteristic of specific geologic formations. So is the T-Rex a good index fossil? Well, T-Rexes can be found over a wide distribution. We can find T-Rex in Asia, in North America, so it would check off that box. T-Rexes are also of a narrow time range. As we can see, the T-Rex itself was actually only alive for about 1,000,000 years. So, yep. Unfortunately, T-Rexes are not characteristic of any specific geologic formation because we only have found about 100 T-Rex fossils. So this one is no. We have not found that they are characteristic of any specific geological formations. Therefore, the T-Rex itself is not a good index fossil. However, there are a lot of good index fossils from the time of the dinosaurs. So these ones right here, scapholites, which are a type of ammonoid or shelled marine organism, can be found over a wide distribution over a narrow period of geologic time. So right about the time the dinosaurs died off, these are when these cropped up, and we do not find these at any time after the dinosaurs died off. And because scapholites during the time of the dinosaurs were so massively abundant, they are characteristic of a lot of sedimentary beds in the time of the Cretaceous, which is the time that the dinosaurs were alive. So these are very good index fossils. Here we have different visualizations of geologic time. So we are currently living in the Phanerozoic eon, in the Cenozoic era, the Quaternary period, and the Holocene. So they're just increasingly small periods of time. The dinosaurs also lived here in the Phanerozoic eon. It's a massive amount of time. But they lived in the Mesozoic era, and they lived from the Triassic to the Cretaceous. They went extinct on the Cretaceous-Paleogene border right here. On the picture to the right over here, we can see that same event. That's marked by a big extinction. So obviously we know that the dinosaurs went extinct. So we'll typically find that geologic eras are distinguished by major events like extinctions. So down here, in the boundary between the Paleozoic and the Mesozoic, that was marked by a gigantic extinction. That was actually known as the Permian extinction, which killed about 97% of all life on Earth, whereas the dinosaur extinction killed about 75% of all life on Earth. So there have been many worse extinction events than the dinosaur extinction event, although the dinosaur extinction event is obviously a huge event in Earth's history. So in the last age of the dinosaurs, the end of the Cretaceous period, the world was much warmer. There was basically no glaciers, no ice, anywhere globally. The continents were a lot closer together. The supercontinent Pangaea was basically breaking up at this time, or a little before this time. And we see a lot of the same species that we see today, other than the dinosaurs. There's lots of birds that we would recognize, different types of mammals, alligators, Flowering plants and different types of ferns were also alive at this time, so it's not that much different than the world we had today. A little bit warmer, continents were in different places, but pretty much roughly kind of the same as today. Okay, so this is the big one right here. A 6-mile wide impact crater struck the northern Yucatan Peninsula in Mexico. It's known as the Chicxulub impact. It would have caused a layer of ash to block out the sun, and everything within a very large area of the impact would have been immediately vaporized. This impact fundamentally changed a lot of the Earth's system at the time, and these changes from cold temperatures from the sun being blocked out to fires spreading all over the world would have killed off about 75% of all life on land and in the oceans. This was the end of the era of the dinosaurs. Okay, so how do we know that this happened? Well, we do have a few lines of evidence. First, we have all over the world, and we'll see on the next slide too, but we have this distinct layer of clay and ash that is found really all over the world at this time. We know that this layer came from a crater, an impact crater, and not something like a volcano, because we find a lot of the element iridium in this layer. And we know that iridium is typically only abundant in asteroids and other space objects. So this ash layer is really cool because when you're looking at something like this, and again, this is found all over the world, you are looking at the Cretaceous, which we usually symbolize with a K, and the Tertiary or the Paleogene period, which we'll symbolize with a T. So below that line, we find dinosaur fossils. Above that line, we find 0 dinosaur fossils. This is where the dinosaurs died. Another line of evidence that we see commonly with a lot of impact craters, and so we definitely see this with the Chicxulub impact, is this right here on the upper right image. These are called spherules. So what these are just really, basically they're really hot pieces of rock that got wound up and thrown out of the crater. And so this image on the upper right is a relic of the Chicxulub impact, and this was actually found right here in Texas. So these spherules traveled a long way, and they can be traced directly back and dated to the time of the Chicxulub impact. So we do know that this is another line of evidence for impact craters and definitely the Chicxulub impact itself. So as I mentioned, we can see this marker layer pretty much everywhere on Earth. North Dakota, Denmark, Italy, Mexico. What you're looking at right now, again, is the boundary between the Cretaceous and the Paleogene or Tertiary period. So we are actually able to pinpoint exactly where the Chicxulub impact occurred in the rock record. So we do know where the dinosaurs died. This is known, it's kind of like an index fossil. It's known as a marker bed. And basically what it is it's a bed, a rock bed, that's distinct of a significant event in geologic time. Alright, y'all. I hope you learned something about marker beds, index fossils, dinosaurs themselves and the time they lived, and their tragic extinction. If you have any questions, please let me know. Thank you.